Hello everyone and welcome back to part 2 of the Space Encounters repair. I've got this thing all set up with the angle brackets on it and got it running. Remember, it's flashy. It flashes a lot with the scrolling ground. And what I want to do is focus on this area right here first, this 4-chip block. Starting with the adders. Because remember, adders are used in positioning type stuff. See how this kind of thins out? It starts really big and it'll thin out. Or does it? Yeah. See how it does that kind of stuff and it's flashy? So I believe we're going to start right here. I'll get the analyzer set up. And first we'll do these two 7483 chips. Then we'll move on to these 298 muxes, and I'll just verify all of this stuff. This doesn't have a traditional bit shift that most 8080 stuff has with the shift registers and stuff. This does it through these up-down counters and adders and stuff like that. So that's where I'm going to start, is right here in this block and move out from there. So hopefully we get lucky and it's just one of these, or something like that. Everything else, like this side, is all like control input and stuff like that, really. I'm not really so much concerned about that as I am this. So I'm gonna, like I said, let's start right here. So I'll get the analyzer set up for 7483s and yeah, go from there. Alright, I am on the first of them. This is M4, so that is going to be this guy. And it looks as if A input is always 0. So, yeah, it is. It's always grounded. See that? So, okay, so this isn't actually adding. This is almost like it's used as a driver, because it's always adding to 0 on every bit. See that they're all of the A inputs are grounded. So whatever is on B is just being driven out. Yeah, weird. So that's actually doesn't even look like it's being used as a adder. If we go ahead and just kind of, oops. We can do that and then do that, and we can move around and you'll see it's just a driver. 2, 3, 4, 5. All of the outputs are the same as the B input. Okay. So, that being said, let's just move over to the other one, because this one's fine. And see what this one's doing. Now, I did see a little bit of an addition there. Right here it's being used basically the same way. It's just driving the B input out to the sum. 11, 12, 13, 14, 15. Now I do see that every now and again that does change to 1. But that looks like all it ever changes to. I could actually, let's go ahead and trigger the, what was it, A input. to 0. Here it's adding 2. So we get 2 and 8 is 10, 2 and 7 is 9, 2 and 6 is 8, 2 and 5 is 7, and then back to 0. Here we're adding 1 to 11, and then back to zeros. Okay, 5, 4, 3, 2, 1, 15, 14, 13. It's like counting down. So far so good. I'm going to mess around with the trigger a little bit. Let's change it to 0, 1 and see what happens. Here we're adding 1, so 1 and 14, 15, 16, 1, 2, 3. One and 6 is 7. Okay, and now we're adding 2, 4, 5, 6. I don't think this will ever happen. I don't think this will ever be a 1. 5, 7, 8, 9, 6, and 5. So that looks fine. And let's look at the schematic here and check this guy out. P4. We're always going to have 2 zeros on the A1 and A3 and A2. A3 and A2 will always be zeros. So, yeah. I don't think we ever get 1, 0 or 1, 1. We're not. Anyway, this was fine. It looked fine. There's nothing wrong with it. Yeah, you see here it's just dropping down. There's no adding going on. That's a 0. So it's just 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Nothing odd. 7, 6, 5, 4, 3, 2, 1, 0. 15, 14. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3. 11, 10, 9, 8, 7, 6, 5, 4, 3. Yeah, it's no big deal. These are good. These are not an issue. So we're going to have to look elsewhere. That's the only 283s, so I can take these down now. And then we will look at these 298s. Okay, so I'm hooked up on the first 298. I got my TTL book out because I've never done a 298, but now I have it saved into my system. 298 is basically a a dual 4-bit word selector. So the chip selects between 2 4-bit words and puts either one of them on the output on the negative pulse of the clock based on what the word select is. If the word select is low, it selects the 0 word. If it's high, it selects the 1 word. You know, there's 2 words, and it selects between It selects between the two 4-bit words and puts them on the output on the negative edge of the clock, synchronous with the negative edge of the clock. So yeah, pretty simple chip. And here we have on the negative edge of the clock, we have A. So we have A on the output. And this looks like it's always selecting 0-bit. Here we have negative edge E, 0, 0. 4, 4, A, 8, 0, 0. A, 5, 5. Negative edge is 5, so it's 5 down here. Negative edge, it's 5, stays 5. Negative edge is A, so we have A down here. And you can see it changes right at the negative edge. Right at this negative edge, you get the change to A, because the 0 word is being selected. If this was high, it would select C and put C down here, but it never does. Here we have negative edge is 4, so we have 4. Yeah, A, 6. This thing works fine. A, both times, 2 negative edges. And then you have 2 negative edges here at 9, so we have 9 down here. 0, 0. 0, 0. 0. 0. 0. Yeah. This thing works fine. So let's go ahead and here's C. Yeah, see that? So we'll go ahead and swap over to the other 298 right here and take a look at it. 2, 2, 2, 3, 2, 4, 2, 5, 2, 7, 3, 2, 7, 3, same thing, 7, 3, 7, 4, 7, 4, 7, 4, 7, 5. Okay. Now, the curious thing about this is it's never selecting the 1-bit. Never. Is it supposed to? I don't know. But for what this is doing, it's not faulty. It's doing exactly what it should. Let's try to trigger on this being 1. It does select 1. See, now we have a whole nother thing to check. Now it's selecting 1, so it's 2. Yep. 2. 2, 2. Is it always 2? It looks like it might always be 2. Yeah, you see that negative edge there? This 1 line is 2, so it's now it's 1, 3, 2, 1, 2. You can see it changing, but it's changing and it's doing what it should do. So I don't see anything wrong. What I need to do is switch this back over to the other 298 and make sure that it's looking the same. This one seems to be fine. Okay, yeah, we would have seen an issue. So let's go ahead and move back over to this one and look at it now. Okay, yeah, we're getting some changes here. 0, 0. These should always match. So if you can kind of just look at it and looks like some nonsensy junk there. I don't know what's up with that. I saw F90 and I saw them both change to the same thing at the same time. That's what I'm looking for right now. If I can notice like one of these being F and the other being D or something like that, I'll know that there's a fault. But so far I'm seeing them change to the same thing. C, E, F, 0, D, C, D, C, F, 0. I saw a 9 in there and they were both 9. So you're just kind of looking at it and making sure that they both change to the same thing. CB950. There's nothing wrong with this chip. I don't like that. But I don't think that. This is at 20 nanoseconds. This is 50. Stop. Now we have a 0 and then a, this is going to be whatever that is, and then another negative at 0. So this is actually working the way it should. Now, should this noisy nonsense be here? I don't know. But this chip is doing what it should. So these 298s are not an issue. So we can move on, and I believe that the next thing was 4 191s on the schematic. So I'll set up for 191s, and there's actually quite a few 191s on this board, so we'll be able to analyze them all at the same time. I just looked over and noticed that it's not doing that anymore. It is no longer doing the flaky. What happens if I remove Yeah, it looks right now. What happens if I remove this? Will it stay good? I don't know. Let's try it. Let's go ahead and remove this off of there. Now it's flaking. See that? It's back to flaking. Interesting. It's not doing it nearly as bad as it was. Yeah, there it goes. Big time. Let's put that back on there. And quiets right down. So if we remember, there was some flakiness going on this chip that we saw on the analyzer, and I said I don't know if that's supposed to be doing that, but it looks like this chip is not the issue, but this chip could be the issue. This chip could be internally causing some flakiness on that line. See this junk? And this right here could be what we're seeing on the screen, this flashing junk right here. That could be what's actually making it flash. So it's like, okay, what do we do? Do we just replace everything that's touching this chip? You know what we can do is we can analyze what is, this is 5P. This is P5. Which is this guy right here. So our problem could be this chip, this 283 that we looked at, could actually be a problem. I don't think so. I'm actually thinking that this 298 is probably the issue. But yeah, the output of this is inputting this 191, which could be causing errant outputs on the one. I think I would start with this guy. This 298, I believe, is probably our problem, causing this errant nonsense. And when I actually put some capacitance on it, put a little bit of interference here on it, or capacitance to straighten it out internally or something like that, it straightens right up and there's no more flaky. So I'm going to see if I have 298s, and this is a great example of using the analyzer to see something. Now I don't know exactly, I'm not going to sit here and tell you that I know exactly for a fact that it's this 298. I have an educated guess that this 298 is causing that little interference junk, because I don't believe that this 191 would backfeed to that chip. I think this is the culprit because it is what is driving. This chip is what is driving this counter. So I think this is going to be our problem. Now, I don't think it is this data, these data bits that are feeding it. I don't think that's the culprit, because that would cause issues with a lot of other stuff. This is the main data lines, I believe. So I don't believe that that is the issue. I think it's just this chip. We'll give it a whirl. I'm going to go ahead and replace that guy and see if that changes, or see if that fixes our issue. Because as of right now, it works perfect with that, with the analyzer kind of acting as a interference filter or something like that, adding some kind of capacitance to that chip to straighten it out. So yeah, let's do that. Let's try a 298. $290, $299, $290, $299. Darn it! I don't have any 298s. Well, it looks like I'm going to have to make a spot. Crap. Alright, well, I guess I'm going to have to order some parts. I have to put this one on hold for a little bit. Yeah, just this analyzer being connected to that chip. I got it just connected, but it's not even turned on. Just having it connected settles that chip down, that 298. So yeah, I really think that is going to be it. So yeah, I got to go ahead and order some 298s. And I'll be back. through the, yeah, it flashed once there, but that's because it's, this thing, yeah, I just got to get some of those chips, that's all. All right, I'll be back. Through the magic of YouTube editing, it'll be a week for me or something like that, but it'll be a snap of the fingers for you guys, so I'll be back. Well, it turns out I didn't have to wait quite so long. One of my parts boards right here had a 298 in it right here. So I scanned that, put it in this board set, and we get the same flashy stuff. I think, right? Yeah, see? All right, so we continue to look. And we already have a clue that something that is attached to that chip has an issue. Because when we put the analyzer on it, it settles down. See, right? It's really getting, the longer it goes, the worse it gets. So my guess is it might be one of the clock signals or the select signal or something. Maybe the clocking signal is bad or something like that. I don't know. We'll have to keep plugging away. But yeah, it's getting, the longer, the hotter something gets, the worse it gets. So it's not that 298. Okay, I have replaced the two RAM chips. There's a 27LS00 right here and a 7489 right here. I did desolder those and remove them, so I want to test these out of circuit. I just wanted to eliminate the RAM because RAM is not something that you can easily check. And we get the same thing, so it's not the RAM, it's still doing the flashing. So it's not the RAM. And now I've got my analyzer on those and it's not settling it down. Right here I'm just running it on that 289, one of the 289s. And it's fine, but yeah, that wasn't the issue. So it's something else we're going to have to keep looking. I just wanted to eliminate these RAM as being flaky, and it's not the RAM, so I'll put these back. I'm going to test these in my Inquisitor and then put them back in the board. If they test good, of course. So, yep, that's another thing eliminated. Now, as I had planned before, I think I will set up my analyzer for 191s, and there's 4 191s to check. These 4 right here. So we'll check those. I've checked the RAM. This is the 27LS00. I've checked that guy. There's some 161s right here that address that RAM, and this is just a line buffer. So I don't really think this has anything to do with anything, because this would, if this was bad, it would cause more of a static type issue. You know, we can simulate that. Let's remove that RAM. Come on. It's my chip puller. There it is. Let's just remove this and turn it back on and see what it looks like without the line buffer. Yeah, without the line buffer, you just don't get the lines. It's more of a static issue, but it's still really flashy. See that? Yeah, we shouldn't be getting that flashiness, so. Yeah, it's not the RAM. it's probably the one, these 191s. Yeah, this here, what is this business? This is video out. This might be where the video turns different shades of white or whatever. This might actually, this has got something to do with an intensity circuit right here. So I would say this is probably the intensity of the screen doing this, you know, going white and then coming back. If we can hold on a minute and watch it do that. You see, it doesn't just turn all white and then turn all the way back. It kind of goes in and out. It's like a fade effect. And I think it's coming up right here. Yeah. It's kind of a fade effect a little bit. It's quick, but that's got to be this circuit right here. And this is video. See, it could be anything in here. So we're just going to have to keep plugging away. That's all there is to it. We'll find it eventually. And both of these RAMs do in fact come back okay in the Inquisitor. So I'll put the originals back in and we'll move forward. Okay, now I am looking at the R5-191, and these four counters right here are acting as bit shifting because they count up and down, so they're shifting bits up and down as needed. And this one outputs this ripple signal to enable the count of this one, and likewise here to here. So I'm looking at this guy right now, and if we look at the our TTL data book, I was just getting a general view of how the ripple and the min-max work on these, because they're all a little bit different, and it's good to have this book so that I can just refresh what I need to look for. And it says right here, the ripple clock output produces a low level output pulse equal in width to the low level portion of the clock input when an overflow or underflow condition exists. So the ripple will be high as long as the clock is low when it over or underflows. And the min-max okay, the ladder output, which is the min-max. Okay, the two outputs have been made available to perform cascading ripple and min-max count. The ladder output produces a high level output pulse with the duration approximately equal to one complete cycle of the clock when the counter over or underflows. So those two counts work different. The ripple is a high pulse that is the length of the low level of the clock, and the min-max is a high pulse within the complete cycle of the clock. So I've got a snapshot of this guy, and we'll look at it, and unfortunately my camera is dying. I didn't charge it. Anyway, this is a snapshot of that guy right there. Here's our enable line. Here's enable. And we have our down, up, and this is counterintuitive. It counts up when it's low and it counts down when it's high. Here's your clock. Here's the data input. Here's load actually. There you got a load signal, data input, and your count, and your ripple, and your min-max. Okay. your minimum maximum. Now the ripple, I thought it said it is a high. Let's look at it again. The ripple, nope. The ripple clock produces a low level output, so it's high going low, and that's what we see here. It's high and it goes low, and the min-max is low and goes high. So we've got our count here. It's enabled now, low enable. So it's counting 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And now we get to F here, and that's the overflow, right? So it overflows, and while the clock is low, you have a low level on the ripple. But the min-max is a complete cycle of the clock when it over or underflows. So the cycle of the clock is high, low, back to high. That's the cycle, and that's where we see this high. So this actually looks fine, and now we're still counting. We continue 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, and it happens again. You get an overflow, and the ripple is low, the duration of the low of the clock, and the min-max is high for the complete cycle of the clock during the overflow condition. So this looks fine. Now I do need to check a couple more situations here. I like to trigger on, let's say, just disregard the clock. I want to trigger on a load signal and make sure it's loading properly. And let's zoom out a little bit. Here's a 4. It's already 4 though. Data in, and this was already 4, so it doesn't. Yeah. Okay. Yeah, that's underflow. So the duration of the clock cycle. This is there are stipulations in here that say you may get a false trigger on certain situations. The thing is this system does not use this. The system doesn't use this line at all, so this is kind of irrelevant. This is the only one we care about, is this ripple out. But yeah, I don't see this not working. Okay. Here you see load on the low, and it goes to A. And we're not enabled. So the load must be an override, right? Because it's loading. Let's see how load is supposed to work. The load pin should be, the way I'm seeing this, it should be asynchronous. It should not be synchronous with a clock or anything. As soon as this load went low, we see on the output A. See that? As soon as the load went low, it sent A down to the output. So it should say that load is asynchronous to the clock and overrides the enable. So I want to see that. Okay. Here it talks about false clocks. Okay. Up, down, and load inputs are buffered. It's significant. Okay. All right. Yeah. Asynchronous, presettable with load control. Asynchronous means it is not in sync with the clock. It works separate of the clock. So that is exactly what we see. So that's correct. That's what we should. It should have said that, because that's working outside of the clock. So this one seems to be working fine. We've got our load. We've seen everything else working. So yeah, I'm going to call this one good. I'll just sit here and play around with it and do some more snapshots and whatnot. But and I'm going to charge my camera. And yeah, I'll be back. Okay, have not charged the battery yet, so this is going to be really quick. I got through analyzing all of the 191s here, 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 and here, and they all look fine. There's actually another one right here that I didn't do that I should get on and just make sure it's... I'm still set up for it, so I will do that, this one right here. But this board set is just weird because those all look fine, those 4 chips. And now it's just not doing that no more. That flakiness, that flashy flakiness. Yeah, I don't know what's going on with this thing. Why it likes to flake out every now and again, but now it's not. I'm just going to sit here and leave this thing on all day and see what happens. Could that be some kind of a connection in the where the boards connect together? Maybe. I doubt it. I don't think so. Anything's possible, I suppose, but I'm not seeing anything logically wrong yet. I have seen where it seems to be unrelated to having the analyzer hooked up to it when it straightens out and doesn't do that. So I don't exactly know why it's doing that. But I'm just going to leave this thing on all day. It's early in the morning. It's about 10 o'clock. And I'm just going to leave this thing on all day and let it cook and see what it does. But I am going to fire the analyzer back up, and I'm going to jump on that last 191, check it out, make sure, look at the circuit, how it's working in the circuit, and just analyze it and make sure everything's looking like it should. But yeah, this thing looks perfect right now. Right now there's no issue, so I'm just going to let it run and see if it fails over time or what's going on. I don't know. But I'll charge the camera and I'll come back later. Okay, we're back with a fully charged camera. And when I left off yesterday, this thing was still acting a little flaky, and I had just decided to leave this thing running all day yesterday, and I left it running for about 6 hours. And when I came back to check on it, it's dead. So, yeah, it's got some weird arrow type pattern going on. I don't think my camera's sophisticated enough for me to change the shutter speed or whatever. So, yeah. Anyway. So it died on me, which is good. I'd rather have it just, if it's going to be flaky, I'd rather it just die. So I am going to figure out what's going on here. This is obviously a CPU board issue, so we'll flip this thing back over. I'll get the fluke back out and redo my ROM and RAM checks and see what's going on with this thing. And it's either going to be something on that board or it's going to be something on this board corrupting the whole data lines. And that's very possible, like a 174 or something that interfaces with these data lines. These data lines come up and they're interfacing with these counters and this other kind of stuff. You know, we'll just have to go through, and if it's not the data lines on this, if it's not being corrupted by this, then it's just on this big board. So we'll get the fluke out and see what it tells us. Okay, I've got the fluke out on it, and I'm getting a decoding error on RAM, and I'm getting wrong signatures on here. If I do an auto test, it's okay. A bus test, okay. Let's do a RAM check. And let's just go to 3000 to 37FF, and it'll kick back a decoding error, I'm sure. Probably bit 4. That's what it was before. Maybe. Yeah. Okay. Decoding error bit 4. So the fluke doesn't like address bit 4. Okay. And we get incorrect signatures here. So I'll get the little scope turned on and we'll probe address bit 4 and see what's going on with it. Alright, we're going to do a little bit of fluke address bit toggling. Let's start with toggle address at just the ROM, any of the ROMs. That'll toggle every one of these. You know, they're all bust, all of the addresses are. So we're going to start with address bit 0, toggle bit 0, and loop. Okay, now we are looping, toggling address bit 0. So if we go to address bit 0, which is pin 8, so 12, 11, 10, 9, 8, and you can see address bit 0 is toggling, right? Okay. Now let's start over. We're going to do address bit 1, which is going to be 1, 2, 3, 4. This is going to be address bit 1. Right now you can see it's just low. It's not doing anything. It's not running at all. But we're going to go ahead and toggle address bit 1 and loop. Okay, so now we'll go to address bit 1. Here's 1, 2, 3, 4. Here's address bit 1. And you can see it toggling. Right? Good. Let's skip right to address bit 4. Just you hit the auto button or the bus test, and that basically stops this from doing anything. Now it just sits idle. You can see all these address bits are just idle. They're just sitting here at 0. Right? So now we're going to toggle address bit at ROM bit 4 loop. Now we're looping, toggling address bit 4, which is going to be 1, 2, 3, 0, 1, 2, 3, 4. This is address bit 4, and you can see it is not toggling at all. So, yeah, and this is going to be address bit 3. Yeah. Anyway, here we go. Let's do this. Let me get the schematic and find out. It's one of these 08s. So let's figure this out. Okay, and unsurprisingly, address bit 4 is this chip. Remember the one that was broken? I said it was broken earlier. It's 4 and 5 out to 6. So I got the CPU back in it. We're going to fire it up, and I'm going to probe 4 and 5 out to 6. Here's the high all the time signal, I guess. Here is address bit 4. So we have a high all the time, we have address bit 4, and it is low all the time. That's just dead. So yeah, that 08 has died on us. And you know, that could, I mean, it's kind of, I don't know if I buy that this was the problem all along. But it could be if we had a flaky address. I don't know, that would, I don't know, that because this is also buffering to address the ROM. If the program was running, then why wouldn't it fail like that? You know, if it's, I don't know. I think this is unrelated to our problem on this board with the flaky flashing. But we do have to replace it so that we're back up and running. So I'll go ahead and stop, get this thing out of here, put a new 08 in it, and move forward. Okay, replaced that 08. And we are back to working. And we'll see if it starts flaking out again. I'm not going to make you sit here and be bored about it. I'll just let it run for a while and then come back. I think it's still flaking out. See that? It is definitely still flaking out. You know what I think I'm going to do? It'd be easier if I can just whittle down which board is the issue. It's got to be the backboard, the board on the back. But it could be. No, I don't see this being the CPU board. This has got to be an issue on the backboard. So yeah, this is definitely that backboard. So I've been through the 191s, I've been through the 298s. There's some muxes. There's a lot on there yet. I've verified the RAM are good. So there's still a lot on here that could be. It could be a simple gate causing like with an errant high pulse or low pulse or missing a pulse or something. It could just be something really simple. So before I suspect this being the bottom board, which I don't see this being the bottom board, because the only thing that really comes up from the bottom board are the address bits, the data bits, and some of the control lines that are made on the CPU board go up there. But they're also used on the CPU board. So if the CPU board was not working, it wouldn't even be doing this, right? If the data and address and stuff weren't right, then it's not that board. It's the backboard. It's processing. It's the processing on the backboard is what it is. So I'm just going to have to keep, continue with the circuitry on that backboard and find out whatever's flaky. Unfortunately, this is not a dead chip problem. This is a flaky chip problem. This is not something that you would be able to fix with a logic probe. This is going to have to be done through analyzing and stuff. So you can use the small scope on simple gated chips for just looking at the waveforms. But for the more complex chips, you definitely need the analyzer. But I think what I've done already is I've analyzed most of the more difficult to look at chips. There's a 157 on here, and I don't know if it is enabled all the time. If it is enabled all the time, I can use the little scope, my 4-channel scope, to look at that. But if pin 15, if the enable is actually a toggling signal, then I'll have to use the analyzer. So a lot to look at yet, and yeah, so we'll do that and see if we can't figure this out. Well, I have been just testing around on this thing. I think I've tested that, that, these have been tested. This. These two 161s are in the line buffering addressing for this RAM, and I don't think that has anything to do with anything. And it's just not funky now. Now it's been sitting here, I've been watching it, and it's just not flaky. I haven't really been paying attention while I was working on it, but now I don't know. This is a problem that I don't think I can fix because it starts out and then it disappears. Let's turn this thing back off and give it a couple of minutes. I'm just going to turn this off and let it kind of settle down a second. I replaced both of these electrolytics that were on this board. They tested good, but they had a high ESR, the ones that were in it. Had like 10 ohms of ESR when normal is around 1 ohm, 1 to 2 ohms. And one of them was up to like 10 ohms of ESR, the other one was like 9, so they were high ESR. Which just means that they're gonna leak a little bit. They're a little leaky. Putting a little bit more strain on a power supply, the 5-volt rail. Yeah, so I don't know. This is a weird one. Let's go ahead and start her back up. Let's see if we get the little flashy nonsense. And we do. Yeah, see that? Yeah, there it is, flashing. Oh, weird. Okay. Well, I'm going to let it sit here and run for a while and just kind of watch it and see if it clears up. I don't know if this is one that I'm going to be able to fix without just replacing parts. I believe that there's just a part on here that looks like it works, but just internally has a characteristic that it just doesn't work right, but it looks like it works. You know, I've seen that before where a chip tests okay and works and looks like it works, but it just internally something's wrong with it and it just doesn't work. Maybe it draws a little too much current, or maybe internally it doesn't allow enough current through the chip when it goes low and it's supposed to be sinking current. Maybe it won't sink enough current or something like that. You know, and it's not switching properly or something. I don't know. Something in one of these chips just isn't right. So, who knows? All right. Look at it. It's going crazy. Terrible. All right. Okay. So, interesting development. I pulled my board out of my Space Invaders Deluxe because it is the same main board as Space Encounters, and did a little swapperooski. So this is my main board, my Space Invaders Deluxe main board. I put the Space Encounters ROMs in here, and the Space Encounters board. And I've seen no flaky. And what I can do is leave the monitor on and just unplug the game, because I want to see it immediately as it comes up. Because if you remember, it would start out doing the flaky flash, and then over time it would quit doing it, which is weird. So I don't know. I'm going to go ahead and now I'll plug it back in, and you'll see there is no flaky flash. It doesn't do it. Yeah, so I don't know. It's on the main board. Remember I was saying I didn't think it was the main board because it's just there are some control signals that come from the main board, but mostly it's addressing and data. And if the addressing and data were flaky, it wouldn't even run. So it's got to be another signal, or it could possibly even be the edge connector. It could be a connection. So I'm going to continue to play around with this setup the way this is and see if I ever see any flaky, because I haven't seen it flaky flash yet. And I don't think it's going to. I think it's a problem with a connection. It's probably that big green connector on that thing. So let's go ahead, turn it back on. And we're running. And yeah, it's solid. It just doesn't, it's not the backboard. So I've been analyzing that backboard and not finding any problems. It's because the problem's not on that board. So I'm going to start looking at signals that come from. First thing I'm going to do is I'm going to go over to the microscope and analyze and look at that thing under the microscope, that green connector, and see if it could be a connection issue from that board to this board. So yeah, this thing just doesn't flash. It doesn't do that. So yeah, one more time we'll go ahead and just turn it off. Give it a sec. Remember, we would give it a second and then we'd turn it back on and we'd get that flaky nonsense. So now we'll go ahead and turn it back on. Yeah. It just doesn't do it. That's 100%. It's a connection. I think it's the green PCB interconnect. I'll be honest with you. I think that's what it is. I think it's a flaky connection between the two boards. So I think what I'm going to have to do is replace that connector. I've already done it on this. On mine, my Space Invaders Deluxe, I put a new connector on it a long time ago. Those things are a common failure. And I have seen to where your video will be flaky if you have a flaky connector. It'll do flaky things. I have seen that before. So, yeah, we'll just have to, I'm going to have to replace that. Alrighty. Well, I will do a few more tests and stuff and let this thing run around a little bit, turn it on, turn it off type of stuff, and yeah, I'm going to end up having to replace that connector. Alright, I'll be back. Okay, got a new heavy duty connector in there, soldered in nicely, cleaned up, nicely soldered, nicely cleaned. Okay, I'm going to put this back together as Space Encounters and we'll see how it performs. Okay, I have this thing all together, back together as Space Encounters and running, and interestingly enough, now it's completely flaked out. This is what it was doing, but very, very sporadically. Now it's actually doing it big time, which is actually good. If you're going to fail, fail. So, what in the world? Do we have is there a connection issue? I guess I got to check all of the signals coming up from this board through here. Did I expose a problem that was like a bad trace or something? Let me look at this a little bit closer. It's got to have something to do with the connection between the two boards. All right, I went ahead and made this Space Encounters board that I'm working on. I turned it into I put my Space Invaders Deluxe ROMs in it, put the Space Invaders board on it, and I'm running it, and it looks okay, but you'll see it resets. See that? So there is definitely something wrong with this main board. The main board seems to be the issue. So, interesting. Okay, well, that's informative, so we'll look into this. All right, I got the fluke back on it, and I just did a long RAM test on the whole RAM range from 2000 to 3FF, and it came back okay. I did all of the ROMs again. All the ROMs are good. I can run this on the fluke, and it doesn't flake out. But I put a 8080 processor in it, and it's completely flaky. I will show you that. Okay, put this 8080 back in it. This is the 8080 that came in it. And it's completely flaky. Now I'll stop it, I'll turn it off, I'll put a different 8080 in it, and you'll see. Okay, put another one in there, and it is better, but it's still flashy flaky. It is better. Yeah, so there's something on this board. Something on this board is not right. What in the world? Something on here is just not drivable or something. I don't know what it is. It's okay with the fluke in it. I mean, it could be these could be an issue, maybe. I really don't know. This is a weird one. This is almost you just got to start replacing parts, to be honest. You know, it wasn't this. It was not this thing, but that's better anyway. It is something with this. So I'm going to have to look into I'm going to look at the schematic around the CPU, and one of the signals coming to the CPU or one of the signals being driven out of the CPU and processed out here, something ain't right. Something's not drivable to the CPU, but it is to the fluke, which is weird, but well, we'll keep plugging away and try to get this, try to find out what chip is flaky, because that's what it is there is a flaky chip on here. So we'll keep looking. Well, I figured out what was wrong with it. Yeah. There was no logic issue, even though I do believe that there is a chip that this thing is drawing more current than it should. Because you really need a Midway power supply on this so that you can adjust all of the voltages. I can't adjust all of the voltages individually with the switcher that I use. I had set my voltage. I'd set the power on this to the 5 volts, brought 5 volts up to about 5.1 volts. I measured my -5 and my 12, and -5 was like 6.5 volts. -5 was up to like almost 6.5 negative volts. And the 12 volt line was at 13.5. So I had to turn that way down. I got the -5 now at -5, but the 5 volt is like 4.3 volts. Or something like that. So you really need a Midway supply on this one to dial in the individual voltages. But yeah, that's why it was flaking out, and that's why different CPUs acted differently. So if you guessed there's really nothing wrong with this board, it is just a power issue. Now I will say there is this board, and maybe it's because of these EPROMs. That could be, these could be power hogs. I don't know exactly. But yeah, that was wrong. That's what was wrong with it. Is this thing's drawing on the 5 volt line. It's really drawing a lot of current, more than I've normally seen on an 8080 board. Yeah. More than I have seen. But yeah, it doesn't flake out anymore if you just set the voltage down. Now if I had the 5 volts at about 4.9 and then the -5 set right at -5 and the 12 set right at 12, it would be perfect. But I have to turn it all down. The 5 volts is down to about 4.25 volts or something like that. And it works perfect. Yeah. So it is what it is. All right. Yeah, I got to move on from this one. This one is done. There's nothing really wrong with it. It draws a lot of current. It's got some power hog parts on it. You know, something's going on there. I don't know exactly what. My suspicion is the EPROMs are probably drawing more current than they should or something. And these things are power hogs, these parts right here. And this thing, I don't know what powers that. And then, of course, you've got the RAM. You know, the RAM take 5 volts, everything on here, you know. So, yeah, who knows? Who knows? It's weird. But, yeah, it works fine. It works fine if you get the voltages right. But those RAM, I believe it's the RAM, the video RAM, or the CPU itself does not like -5 being that high. And that's why it was causing flakiness. And that's why when I pop a different CPU in, it would behave differently. Yeah. Yeah, but that's it. I'm moving on. Alright, guys. Well, a lot of maintenance I did on this one. I replaced all these sockets. I replaced a couple RAMs. We had a bad 08. We had a bad 157. I did replace this, which I'm not I'm not sad that I did that, because that's way better than the original. It's not even close. That's 1,000 times better than the original connector. I analyzed about everything on this board. There was nothing bad on this board. No, there wasn't. Nothing was bad on that board. So that's it. Space Encounters. Customer did not send along the soundboard, so I cannot test that. And yeah, so that's it. We'll see you later. Bye for now. See you on the next. Hey guys, before I go, I just had a thought. You remember when I had this, when this connector was still in the board, and I had this thing running and it would flake every once in a great while. Remember that? I did not mess with the voltage at all when I removed this, replaced it, and put this board back in. And as soon as I did that and I put it back together, remember, it was really super flaky, crazy flaky. All I did was replace this, and it went from being flaky every once in a while, and then it would stop being flaky, remember, and it would kind of smooth out. As soon as I replaced that, it was immediately super flaky. And I think what was going on was I had a bad connection. I was losing voltage or something through this, and I had to crank it way up to get my 5 volts or something, or whatever. And as soon as I got a better connection on there, it went totally flaky. So I had to turn the power back down. I could actually probably get away with putting the 5 volts at about 4.75 with this, and it would be fine. I always have an issue. Every 8080 board that I do, every 8080 system that I do, I always have an issue with the power supply. I can't get it quite right. I can't get it all. I usually have to go about 4.9 volts, and then 5 volts is always high, or -5 is always a little bit high. But this time I just kind of brain farted and cranked the 5 volts way up. And I think what was happening was I was losing something through that connector, because as soon as I changed that, it's like the current just jumped way high throughout the system, and that was automatically really flaky, and I had to turn it way back down, so I don't know, it's just kind of a strange issue. But I do believe that I was losing some connection through this to through there, and as soon as I replaced that, all of a sudden it really manifested itself. It was completely flaked out, so it went from a little flaky every now and again, and it would eventually settle down and be okay, to it was completely flaky when I replaced that. So, and I had to turn the power back down, and now it's fine. So I do believe that this probably fixed this board, replacing this. So yeah, but I believe that's why Midway uses a power supply that has individual adjustments for each voltage, is because it just doesn't work good with a switcher, because you can't, it's not like you set 5 volts at 5 and then this will be -5 and the other will be 12. It doesn't work that way. So yeah. All right, I just wanted to chime in a little bit. But yeah, this looks perfect. There's no more flakiness at all. So that was the issue. All right, guys, we'll see you on the next Classic Arcade Repair. Don't forget to like and subscribe and all that good stuff. And check out the members only section and Patreon. Thanks a lot. We'll see you on the next.